everyone. My name is Saket Kumar Singh. I am working as an assistant professor in Department of Computer Science Engineering, Ajay Kumar Engineering College, Ghaziabad. So, in our previous lecture, we have already seen some of the operating system structures, introduction to operating system, its structures, how we can classify different types of operating system, what are those different types of operating system, what are the layered approach. Okay. So, in continuation with that lecture, today I am going to discuss one very much important topic, that is your kernel and its types. So, in our last lecture we have already seen some of the structures, some of the operating system structures, like first was your simple structure and then second was your layered structures. So, today we are going to see two more structures, but before studying those structures, before understanding those structures, it is very necessary to understand this concept of kernel. So, okay. So, let us start. So, my today lecture outline will be, first I would like to discuss what is kernel, okay, and then we will see how it is different from operating system, because a kernel definition is very much resembles to the definition of operating system. So, we will see how an operating system definition is different to this kernel operating system. Okay. Then next we will see kernel wise design approaches, or kernel wise operating system structure. What is kernel wise operating system structure? Okay. So, you can see in our last class we have already seen two structures. One was your simple structure, which was followed, a simple structure was followed by MS DOS operating system, and we have seen layered architecture, layered approach also, but today we are going to see two more approaches which is based on this kernel. Okay. Then next we will see this is the first operating system structure, which is your monolithic, and second is your micro kernel approach. Okay. And then we will again also see this modular or hybrid kernel approach, or you can say a operating system structure. Among these three, we will see how this modular or hybrid kernel structure, operating system structure is is best as compared to above two. Okay. And then we will see one of the very emerging topic, that is your reentrant kernel. Okay. So, now let us define what is a kernel. A kernel is a central part, a core part of operating system. Okay. Though operating system, what was the definition of operating system? It is a set of program that acts as an interface between user and hardware. Similarly, here also operating system is it provides us the interface, Okay. But what is the difference in between operating system and kernel? A kernel is the central part or the core part of operating system. You can see, you can just draw a diagram like, if this is your operating system, so this is your kernel. Okay. So, kernel is the central part or the core part which is responsible for providing that interface. So, what was the definition of operating system? A set of program that acts as an interface between user and hardware, between computer user and hardware. Okay. So, the list of programs which are responsible for providing the interface is known as your kernel. Okay. So, next, what is a portion of operating system program that always reside in main memory? Of course, if any of the program will be terminated from the main memory, then operating system will halts or terminates or shut down, because kernel is the main part of the operating system. So, it should always reside inside the main memory. Okay. And it provides communication interaction between computer hardware and software component. So, many students gets confused that even the operating system do the same thing as what we are saying here in the kernel, but operating system do these things, perform these tasks with the help of these kernel programs. Okay. So next is, it decides CPU to be allocated to which of the running process. Means kernel decides which process should we provide, the operating system should provide which which process, which it the kernel who is one who decides that हमें किसको देना है. We want to give we want to grant CPU, suppose if we want to grant the CPU among n number of processes, then who will decide? Kernel will decide. Okay. Handles disk management, task management, memory management, etc. So this will be more clearer when we will see the image or the snapshot of the system in our next slide. Okay. Kernel is loaded first into the memory when operating system is loaded. Okay. So we have already seen what is bootstrap program. Bootstrap program, where it is stored in read only memory. Why? Because RAM is volatile. Okay. So that bootstrap program, what does it do? Bootstrap program just load the operating system. So operating system is a set of programs. So the first programs that are loaded into the main memory is the kernel. Okay. Now let's see, it remains in memory until OS shutdown. Okay. So this was the basic things of kernel. Now let's see, this is a snapshot of my system. So you can see here, in our first lecture we have seen this kind of images. Okay, we have seen these images. Now you can see here, you can see the system structure in the performance, that what are the resources inside what are the hardware resources inside a computer system. But if you want to see how many number of programs is being loaded into the main memory, if you want to see that what is the difference between program and process? A program, when its execution starts, means when it's loaded into the main memory, okay, then it names changes to process. So these are the number of processes, you can see these are the number of processes was running, okay, in my system from where I have taken this snapshot. These n number of processes are simultaneously running. Why? Because this is a multi-processor system. Windows follows multi-processor multi-program system. So n number of programs can reside into the main memory simultaneously, and we can perform multitasking. Like you can see, Adobe Reader was also open, Google Chrome, even 50 threads of Google Chrome is running. Microsoft PowerPoint was also running, Paint was also running, Task Manager was also running, Windows Explorer was also running when I have taken the snapshot of this system. You can see how much memory of these applications has taken inside the main memory, how much disk these are using, how much CPU these are using, how much network they are fetching, how much GPU they are using. Okay, so all the snapshot you can see from your task manager inside your computer. Okay. So now the main thing is that, like suppose there is a scenario like if you close any one of this application, okay, if it is not visible properly, let me again tell you. First is your Adobe Acrobat Reader, then second is your Google Chrome, third is your Microsoft PowerPoint, fourth is your Task Manager, and fifth is your Windows Explorer. Okay. So please tell me what will happen if I will close any one of this application. Will the operating system, will the system get shut down? No, nothing will happen, only that application will be terminated, only that application will be closed. But in our next image you can see, even here you can see these are some of the background processes. Background processes are those processes which are always running inside the main memory. Okay. So suppose if I will close this Adobe Acrobat Reader, then the background process related to these apps will also be closed. But these are always, if suppose if you are running some application and some background process which is necessary to run in background, that will always run inside the main memory till the application is live. If you will close the application, the background process will also be closed. Okay. So, these are the simple processes you can see. First is the application processes, second is the background processes, and background processes contains both the things like even a device driver, even a network driver, even a LAN driver, all those are termed inside this, coined inside this background processes. All those will reside inside this background processes. Like let me tell you one example of sound driver. Somewhere in this background process you can see this is 70 background processes were running inside my in my laptop when I have taken this snapshot. Okay. So, among these 70 there may be a Bluetooth driver, there may be a sound driver, there may be a graphics card driver running inside this background processes, which is always running, which is always reside inside the main memory. Okay. But if I will close the sound driver, if I will close the Bluetooth driver, if I will close the network adapter driver, then what will happen? Will my operating system get shut down or hang? No, nothing will happen. Why? Because those are not the kernel program, those are not the kernel process. Now, let us see, this is the another snapshot. You can see here these are the Windows processes, 94 Windows processes are running. In this, if I will close some of the processes like client server runtime, okay, local security authority, if I will close these processes, nothing will happen, only that services will be stopped from the time when I will stop these processes. But suppose if I will close this console window host, okay, or desktop window manager, okay, or a registry. So, these forms your kernel, these are the basic program, the central part of the core part of operating system, which is responsible for providing us the interface, so that we can communicate with the hardware easily. Even the applications, even the softwares can communicate with the hardware easily with the help of these kernel programs. And what will happen if we will close this? If we will close this kernel programs, what will happen? The operating system will either terminated normally or abnormally. Okay. The operating system will be either shut down or it will hang, anything can be possible, or it can crash the entire system. Okay. So, kernel is very important, and kernels are the basic core component of operating system, which is responsible for providing the interface between software and kernel definition. So, there are we have already seen two of the approaches. First was your simple structure, even Mac OS was written by following that simple structure, and then we have seen the layered structure. Now, on the basis of these kernels, the operating system has been divided into three structures, which I am going to discuss. The first one is your monolithic structure. So, monolithic means combined. Okay. So, this will be more clear when we will see the figure. Okay. So, you can see what is monolithic structure. A structure was divided into two separate parts, that is the kernel part and the system programs. Okay. So, the system programs or the application programs, okay, the application programs or the system, what is the difference between application program and kernel? We have already seen that. Okay. So, now let us see, traditional Unix operating system is shown in your figure 3 that we will see in next slide. Okay. So, most work is done by using a system call. When we are using a monolithic architecture, then most of the work are done with the help of this system call. We will see system call in our next lecture. Everything below the system call and above the physical hardware is the kernel. So, this will be more clear when we will see the images. Let us discuss about the advantages of using this monolithic architecture. So, it is faster as less software is involved. Less software is involved means everything has been combined to form a kernel, means in monolithic architecture, when we will see the diagram, Okay, everything is clubbed inside the kernel, and only a fewer components which are not necessary or which are not that holds that much priority has been kept as apart from this kernel mode. So if it is a single software, if it is a single code, if it is a single program, it is very faster because the compilation is very faster for that monolithic architecture. A small source code and compile form fewer bugs, because if it is having a small code and a straight away code, there is no nesting. Okay, so it gives us the fewer bugs. These are the advantages, but monolithic is not generally used because it is not portable, it is not optimized architecture. Okay, so let's see the disadvantages involved in this monolithic architecture. First is difficult to implement and maintain. Difficult to implement and maintain. First, just go through these points and then I will go inside the diagram and then I will explain you this in deep details. Since the modules run in the same address space, a bug can bring down the entire system. Of course, if you have kept all the modules inside a single kernel, inside a single block, and if you want to do a modification inside that kernel, then that can disturb or that can affect all the modules that you have kept inside a single module. Debugging is also difficult. Bugs in one part of kernel can affect other modules also. Bugs in one part of the kernel can affect other modules also. So, this is the diagram. Let us see what is so this is your the users, okay, shells and commands, compilers, interpreters, system libraries, okay, and this part is your kernel. Okay. So, this part from system call interface to kernel interface to the hardware, all the things you can see, whatever the things you are going to study in operating system like signal terminal handling, character input output system, terminal drivers, file system, swapping, block input output system, disk and tape drive, CPU scheduling, page replacement algorithm, demand paging, virtual memory, everything has been clubbed inside a one module, that is your kernel module. So, this architecture and the user applications and shell command, compiler and interpreters are above this, and these are the hardware level. This is your lower level is your hardware level, upper layer is your user application layer, means the users can execute their codes, users can execute their programs in these user layer. Okay, but you can see the basic task, the main functions of operating system, the main functions of operating system has been clubbed inside this kernel mode. Okay, which makes this what are the disadvantages that we have seen. Now, just try to understand that, like suppose if you want to do some update, if you want to update some information in this CPU scheduling, if you want to include some new algorithms of CPU scheduling in your operating system, it would be very difficult because this is a single module. Okay, and for updating this single CPU scheduling, you have to disturb the code of all the modules that are inside this block. Okay, even suppose that there is a error, there is a bug inside this file system code, inside your operating system code, and if you want to update or if you want to debug it, then you have to go through all the code, all the line of codes for these also, and this may affect, this may, if you want to update something inside this file system, this may affect the signal. Suppose these are working properly and there is a bug inside the file system, but when you go and try to update this, try to correct this, try to remove the bugs, this may affect other modules also. So, this is the biggest disadvantage. Let us again see, difficult to implement and maintain, as we have seen. Okay, and since the module runs in the same address space, so bugs can also bring down the entire system. If you want to do a small update, if you want to do a small update in any of the single module that are inside that, okay, so that may bring down the entire system, because while updating this you may disturb the code of this modules also. Similarly, the next disadvantage was debugging is difficult, because if you have clubbed all the modules into single one, so it would be very difficult to find out that which module is showing bug. Okay. So, what is the substitute for this? So, some operating system like the first Mac MACH, okay, MACH operating system was written, which follows this microkernel approach. So, let's see what is a microkernel approach. So, microkernel structure is Mac OS. Do not confuse this with MAC OS, Mac, Apple Mac OS. This is MACH OS, follows microkernel structure. Okay. Researchers from Carnegie Mellon University developed this Mac OS, which follows this microkernel structure. Okay. All non-essential components were removed from the kernel. So, the disadvantages of monolithic architecture has been solved in this microkernel approach, where all the non-essential components has been removed from the kernel and passed into user level layer. Okay. Non-essential components were implemented in user space. User space means not in address, not in kernel address space. Now, all these non-essential components have been shifted to user space. Smaller kernel, now you have made the kernel smaller because you have removed some extra or non-mandatory, non-essential components from the kernel. Okay. Provide minimal process and memory management along with communication facility. So, this is an overhead of microkernel. We will later on see why this communication facility is an overhead. Okay. So, we will see when we will see the diagram. Communication is provided by message passing model. So, this message passing model gives an overhead to this microkernel structure. So, let us see what are the advantages of this microkernel structure. So, advantages of this microkernel structure is ease of extending OS, as we have seen monolithic. So, now we understand that if we reduce the kernel, then we can extend the operating system or update the operating system. Why? Because for performing any update operation inside the OS kernel, you do not have to update all the modules, you will only update the code inside the kernel, because you have removed all the non-essential components into the user space. So, this facility enables us to extend or to update the operating system in kernel or address space. Okay. All new services can be added to user space without disturbing the kernel, which I was saying right now. You can see this is the reason behind this first point. All new services can be added to user space without disturbing the kernel. So, this is the vice versa of the above point. We can also update the operating system. We can also include some new models without disturbing the kernels. Kernel modification is easy due to its size and provide more security and reliability. But the overhead that I told you, and one more important advantage is if a service fails, the rest of the OS remains untouched. OS will run. Why? Because we have removed the extra modules from the kernel. So, if suppose some application or some OS module is some user module get affected or fails, the rest of the operating system remain untouched. Okay. The example is the Mac OS X kernel, which was also known as Darwin. Okay. What are the disadvantages? It suffers from performance decrease due to increased system function overhead. Increased system function overhead, that means if you have just, let us directly come on to the diagram. Example is Windows NT. Okay. So, you can see we have just removed all the unnecessary components and passed it into the user space. This is your user space, this is your kernel. Okay, this is your hardware. So, if you have removed all the unnecessary modules into the above layer, so there should be a proper communication in between these modules. So, this communication was done by the message passing model. So, this communication gave some overhead to this microkernel structure. Now, this is the last, or you can say last structure based on the kernel, a modular or hybrid. So, best current method, this is perhaps the best current methodology for new operating system design, which is based on object oriented. Kernel has a set of core components. So, without wasting time on these points, we should directly go on to the diagram. Links the additional services. The best part of this structure is it links with additional services either in boot time or run time. So, let us see. Uses object oriented programming technique. Overall model resembles layered as well as microkernel approach also. So, this will be more clear when we will see the, you can see some of the examples are Solaris, Linux, Mac OS X. Okay, so, this is the structure of a modular or hybrid structure. You can see this is the core part, this is the central part of your kernel, and all the things either it can be added in the boot time, or it can be added in either it can be added in at the boot time or at the dynamic run time also. So, this structure gives this modular hybrid structure a best popularity. Okay. So, you can see this is an example of a hybrid structure. Hybrid structure means combination of one or more more than one models, more than one structures. You can see this, the first layer in this operating system is layered approach, and this is your microkernel approach. This is an example of a Mac Mac OS X. So, this uses this hybrid structure. This is your microkernel approach and this is your layered approach. So, the last you can see Apple Mac OS X. The last is your reentrant kernel. Reentrant kernel is enables the processes or its corresponding kernel threads to give away the CPU while executing in kernel mode. Okay. So, it enables the process or its corresponding kernel threads to give away the CPU while executing in kernel mode. The best example is a read operation. Suppose if a process is a read operation, then it should not block other process to enter inside the CPU and do its operation. They do not hinder other process to enter into the kernel mode. Disk read operation is an best example for this reentrant kernel. Okay, these are the references. Thank you. We will again briefly look on to this reentrant kernel in our next lecture. Thank you everyone.